Today, our group 11 is going to present 7.4 System of Linear Equation. So, our group member have me, Yong Hao King, Gan Wei Hen, Lim Zhang Xian, Lau Juping, Muhammad Sahir, Numan, and Muhammad Iham. Okay, for this presentation, our group is going to teach you all how to use the matrix and the other method to solve the system of linear equation. Let us talk about what is system of linear equation. So, as you all can see, system of linear equation is the combination of the numbers and the unknown, and it will form the equation. And for this chapter, we are going to use matrix to solve it and finding out the unknown. In this chapter, the system of linear equation, we got 4 types method to solve it by using matrix. So we can use either there's 2 method is under the ERO, and other 2 method is we call it a matrix method. So for the ERO, we got Gauss elimination and also Gauss-Jordan elimination. And for the matrix method, we got inverse method and also the Clement rules. For now, we are going to talk about what is a system of linear equation. For system of linear equation, we got 2 types. One is homogeneous and one is non-homogeneous. Now, let us talk about the homogeneous first. Let us talk about the homogeneous first. So, for the homogeneous, what is the condition? The condition is AX must equal to 0. So, which means the number and the combination of the number and the unknown, which means the equation will be 0. So, there is 2 types of solution for that. One is trivial solution, which is the x will be 0. So, as long as the x is will be 0, they times with the numbers, so it will be 0. So, the equation total will be 0. So, the trivial solution is like that. And for the many solution, the PA must less than the number variable. Okay. Now, let us talk about the non-homogeneous. What is non-homogeneous? The non-homogeneous is the condition is must be AX must equal to B. So that's why the combination of the numbers and the amount must have the answer. So there's 3 types of solution. One is unique, one is many solution, and one is no solution. So as a unique solution, they say that PA must equal to PAB and it must equal to number of variable. And also for the many solution, the PA must equal to PAB, but the PAB and PA will less than the number of variable. And for the no solution, the PA is less than the PAB and it is equal to the number of variable. So let us see how we can apply this solution in our method. Now I'm going to talk about the Gauss elimination method, which is the first method we are going to look to. So the Gauss elimination method, first we need to make sure that we change the linear equation must be AX equal to B, and the linear equation change to augmented matrix, which is A, the straight line, and B. And from the augmented matrix, we change to echelon matrix. After that, we use back substitution, Cx equal to D, substitute back the x, and we can get the solution. Now let us see for example. This is an example question, which is the 3 linear equation, which consists x, y, z. So the first step which I say is change the linear equation to the augmented matrix. So this is the augmented matrix, which means the first column is x, the second column is y, the third column is z, and the behind of this is the answer of each question. After we get augmented matrix, we use the ERO to get the echelon matrix. This ERO which teach in a previous subtopic. So after that we get this, which is the echelon matrix, which you need to make sure that and after that we get the echelon matrix. So after that we get the echelon matrix, we use back the back substitution, we start back the x, y, z, and we can get back the linear equation, and then we just do the substitution. So we can get x, y, z. As the rank of the matrix of A is equal to the rank of the matrix of AB is equal to the number of variable, which is 3, so it is a unique solution. So it is only got each answer for each unknown. So now we are going to look to the second method, which is Gauss-Jordan elimination. So the Gauss-Jordan elimination is same. So the question will be given to you is the linear equation AX equal to B, and we need to change the linear equation into the augmented matrix, and from the augmented matrix we need to change to reduced echelon matrix. which is a difference between the Gauss-Jordan elimination and the Gauss-Jordan elimination, which is Gauss-Jordan need the reduced and the Gauss elimination just need the Angela matrix. And after that, we just use the same back substitution, we can get the answer. So this is a sample question. And as the first step is change the linear equation to augmented matrix, which is same as the Gauss elimination method. And the difference is here. So as the Gauss-Jordan elimination, we need to use the reduced Angela matrix. So we need to change it. So this is only the Angela matrix fit. So we need to continue to do the Angela matrix, reduced Angela matrix, which is this. So after that we get this, we substitute back the x, y, z, so we can directly get the answer. So as the same one, the rank of the matrix A is equal to rank of the matrix AB is equal to the number of variables, which is 3. So it is also a unique solution. Now I'm going to talk about the difference between the Gauss and Gauss-Jordan. As it does not say, the Gauss using the Angela matrix, which is like that. This is a sample of Angela matrix, and the Gauss-Jordan will be using the reduced Angela matrix, which is like that. So for the Angela matrix, you need to substitute back and do one more time substitution. But for the reduced Angela matrix, when you substitute back x, y, z, you can directly get the answer. So this is the difference between two methods. I will pass to another person to talk about the other two methods.
Okay, so now I'll be talking about the inverse matrix method. So first thing first, we must know the determinant of A is not equal to 0, because if the determinant of A is equal to 0, we must stop the calculation because the inverse does not exist. After that, we must let the system of linear equations into the formation of Ax equal to B, where A is an n times n matrix and B is an n times 1 matrix. If A inverse exists, then x equal to inverse of A times B. Okay, so to understand this method, let me show you guys an example. So now we have the system of linear equation, that is x plus y plus z equal to 6, x plus 2y equal to 5, 2x plus z equal to 5. So step 1, we must turn it into the formation of Ax equal to B. So A will consist of 1, 1, 1, 1, 2, 0, 2, 0, 1, and x will be x, y, z equal to B, 6, 5, and 5. Step 2, we must check whether the determinant of A is not equal to 0. So after expanding along the first row, we will get determinant of A is equal to 1 in bracket 2 minus 0 minus 1 in bracket 1 minus 0 plus 1 in bracket 0 minus 4. So the determinant of A is equal to negative 3. So on to the next step, we need to find A inverse by using adjoint method. So the formula of adjoint method is A inverse equal to 1 over A determinant times adjoint matrix A. We can find the adjoint matrix A by finding the transpose of the cofactor matrix. So after calculating the transpose of the cofactor matrix, we get adjoint matrix A equal to transpose of the cofactor matrix equal to 2, negative 1, negative 2, negative 1, negative 1, 1, negative 4, 2, and 1. So after we get the adjoint matrix of A, we can sub it into the formula. So inverse of A equal to 1 over negative 3 times adjoint of A, that is 2, negative 1, negative 2, negative 1, negative 1, 1, negative 4, 2, and 1. So this is your A inverse. Therefore, we can sub it into the formula of x equal to A inverse times B. After we calculate this formula, x will be equal to 1, y will be equal to 2, and z will be equal to 3. And now, we have another method that can be used to solve the system of linear equations, that is Cramer's rule. Just like inverse matrix method, we must let the system of linear equation into the formation of A times x equals to B, where A is an n times n matrix, x and B are given n times 1 matrices. If the determinant of A is not equal to 0, then the solution for the system of linear equation can be obtained. So the formula that can be used for Cramer's rule is xn equal to the determinant of an over the determinant of A, where I equals to 1, 2 until n. And for AI is a matrix obtained by replacing the ith column. As for an is a matrix obtained by replacing the nth column of A by the vector B. To understand even better, I will show you guys an example. So given the system of linear equation, that is 3x1 plus 5x2 minus 2x3 equal to 20, then 4x1 minus 10x2 minus x3 equal to negative 25. And lastly, x1 plus x2 minus x3 equals to 5. So first thing first, we must let the system of linear equation into the formation of ax equals to b. So a will be 3, 5, -2, 4, -10, -1, 1, 1, and -1, where x will be x1, x2, and x3. And as for b, it will be 20, -25, and 5. After that, we must check whether the determinant of a is not equals to 0. After we calculate it, we will get the determinant of a is equal to 3 times 10 plus 1 minus 5 times -4 plus 1 minus 2 times 4 plus 10. And the determinant of a, you will get 20. So for the last step, by using Cramer's rule, x1 is equals to the determinant of a1 over the determinant of a. And it will be equals to the determinant of a1, after I calculate it, you will get 20, 5, -2, -25, -10, -1, 5, 1, and -1. And it will be over with determinant of a that we have calculated, that is 20. And it will be 20 over 20 equals to 1. And as for x2, it will be equals to determinant of a2 over the determinant of a. And it will be equals to the determinant of a2, after I calculate it, it will get 1, 7, 1, 3, 20, 1, 1, -12, and -5. Oh, it will be over with determinant of a, that is 20. So it will be equals to 60 over 20, and it will be equals to 3. Lastly, x3, it is equals to the determinant of a3 over determinant of a. Determinant of a3, it will be equals to 1, 3, 7, 1, 2, 20, 1, 1, and -12 over with determinant of a, that is 20. And it will be equals to -20 over 20. And your answer will be -1. That's all.
Hey, where did you guys go just now?
Just come back from the bookstore.
Oh, I come back from there too.
What do you guys buy from there?
I buy 3 pencils, 2 books, and 6 pens, which cost 37 ringgit.
Oh, me too. I also buy, but different quantities. I bought 2 pencils, 3 pen, and total is 70 ringgit. How about you?
For me, I buy 4 pencils, 5 book, and 1 pen. Then cost me 20 ringgit. Do you all remember the price of each item?
Oh shit, forget already.
Me too, but I think we can use the matrix method that we learned before to calculate the price of each item.
Let's do it.
Okay, after you're seeing the real life problem sample in the video, so now I'm going to explain to you how to do the question by using Cramer rules. So let the pencil equal to x, book equal to y, and pen equal to z. So this is the equation we got from the videos, which is the first person buy 3 pencil, 2 book, and 6 pen, and it costs 37 ringgit. And the second person buy the 4 pencils, 5 book, and 1 pen, which costs 19 ringgit. And the third person which buy 2 pencil, 3 pen, and it costs 70 ringgit. So we change the linear equation into the ax equal to b form. So it will be like this. Next, the second step, we need to check whether the determinant of a is not equal to 0. So we take out the a and we make the determinant of a is equal to -35. So it is not equal to 0. So we can do the next step. So the third step, we are using the Cramer rules, which means the Cramer rule state that the b need to replace for the first column to find out the x, and it will replace the second column to find the y, and replace third column to find the z. So a1, a2, a3. So after that, we calculate the determinant of a1, a2, a3. So we can get, by using Cramer rule, the x will equal to determinant of a1 divided by determinant of a. So equal to -35 divided by 35, -35 equal to 1. As long as the formula, so we calculate out the y and z. So x equal to 1, y equal to 2, and z equal to 5. So which means the 1 pencil is cost 1 ringgit, and 1 book costs 2 ringgit, and 1 pen costs 5 ringgit. So this is a calculation for the real life problem. Thank you. Okay, as you all just now listen to all our presentation, as we introduced to you all 4 methods to solve the system of linear equation, which is Gauss elimination, Gauss-Jordan elimination, inverse method, and also Cramer rules. So for our group, our conclusion is the Cramer rule is the easiest method to solve the system of linear equation. So we recommend to you all, if you all want to solve the system of linear equation, you all can use the Cramer rule to solve it. So that's all from our group, and thank you. Hope you all enjoy.